Something strange just arrived from a dead star. Not a signal from an alien civilization. Not a message. Something much more subtle. A pattern hidden inside the light. James Webb was observing a world orbiting one of the most violent objects in the universe when it detected a chemical signature that made astronomers stop and ask, "What are we looking at?" The planet is called PSRJ 2322-2650b. It is roughly the size of Jupiter, but that is where the similarities end. It orbits a pulsar, the crushed remains of a dead star. This tiny stellar remnant has about the mass of our Sun, compressed into an object roughly the size of a city. And the planet is incredibly close to it, only about 1 million miles away. So close that it completes an entire year in just 7.8 hours. But somehow, this planet still has an atmosphere. And when Webb analyzed that atmosphere, it found something extraordinarily strange. Instead of the familiar molecules astronomers often expect in giant exoplanets, Webb found evidence of molecular carbon molecules known as C2 and C3. This chemical combination is so unusual that NASA describes the planet's composition as unlike any other exoplanet atmosphere studied in this way. And now scientists have a problem, because the question isn't simply, what is this planet made of? It's, how did a planet like this survive around a dead star in the first place? The answer may reveal that planets can survive and transform under conditions far more extreme than we ever imagined. To understand the signal, we first need to understand where it came from. The object at the center of this system isn't a normal star. It is a pulsar. A pulsar is what remains after a massive star reaches the end of its life and collapses. The star's outer layers can be violently expelled while its core collapses under enormous gravity. What remains is an object so dense that a mass comparable to the Sun can be compressed into a city-sized sphere. But the most incredible part is what happens next. The pulsar spins extremely fast. The pulsar in this system rotates almost 300 times every second. And as it spins, beams of radiation sweep through space like a cosmic lighthouse. Imagine standing on a planet while a dead star spins hundreds of times every second, blasting radiation into the surrounding space. Now imagine that planet is only about 1 million miles away. That's the environment of PSRJ 2322-2650b. And yet, the planet survived. It didn't simply survive. It appears to have retained a substantial atmosphere. But the pulsar's gravity is also doing something extraordinary. It is pulling on the planet so strongly that the world is being stretched. Instead of being perfectly spherical, models suggest it has a strange, lemon-like shape. One side is pulled outward, meaning the planet is essentially being reshaped by the gravity of the dead star. And yet, there is something even stranger. The planet is a gas giant, roughly Jupiter-sized, but its atmosphere doesn't resemble Jupiter's. It doesn't look like the atmosphere astronomers expected. So scientists turned to Webb, and that's when the real mystery began. James Webb doesn't need to physically visit a planet to study its atmosphere. It can read the atmosphere through light. When light passes through or interacts with gas, different molecules absorb specific wavelengths. Those absorptions create patterns almost like fingerprints. Scientists can analyze those patterns and determine which molecules are present. And when Webb examined PSR J2322-2650b, the spectrum looked completely different from what researchers expected. There was helium, there was carbon, and most importantly, there were signs of molecular carbon, including C2 and C3. This was the strange signal, not a radio transmission, not an artificial message, but a chemical fingerprint, a faint pattern in infrared light telling us that something very unusual was happening in this atmosphere. And here's why molecular carbon is so surprising. At the temperatures found on this planet, carbon normally wants to bond with other elements, especially oxygen and nitrogen. But if oxygen and nitrogen are scarce, carbon can begin forming molecules with itself. And that's apparently what happened here. NASA reports that molecular carbon dominates only if there is almost no oxygen or nitrogen available to bind with it. That creates an atmosphere unlike anything we have previously observed on an exoplanet. And the temperatures are extreme. The planet's coldest regions can still reach roughly 1,200 degrees Fahrenheit. Its hottest dayside regions may reach around 3,700 degrees Fahrenheit. At those temperatures, this world is not remotely Earth-like. It isn't a place where water oceans could survive. It isn't a familiar gas giant. It's something else entirely, a world dominated by carbon chemistry, orbiting the corpse of a star in an environment violent enough to destroy most planetary atmospheres. And now scientists have to explain how it got there, because this planet wasn't supposed to be easy to explain. Here's where the story becomes almost unbelievable.